Okay, so here's my log file for the MK hexacopter using the GPX tool, and I haven't seen any good videos on how to use it, so I've decided to make my own here. So let's start here. This is the log file, and this was a flight that I took yesterday. Let me find my mouse here. Okay, here we go. So basically this is my, if you look at the extra start here, rather than the flight summary, you'll see that the GPX MK version, here's the flight controller hardware version 2.0, software version is 2.08a, the nav controller hardware version 1.1, and the brushless controller is version 1, software 2.55. And this was the length of the time that I had the unit on, and so on and so forth. My only thing you really need to look here is the magnetic sensor on this unit is internal. So we'll come back up here to flight summary, and you're going to see the date and the time that this flight occurred. This is the flight times, actual flight times, the duration of the flight in seconds, and then in minutes. This was 15 minutes, 15 seconds. This is the battery time, which is the actual flight time versus the on time, which is this one above. Okay, so here's my starting location in longitude, latitude, and the elevation. It's in meters. The GPS altitude. This was my starting altitude, and the highest altitude reached on this flight was 72 meters, which is about 236 feet. My highest vertical speed was 3.2 meters per second. Maximum speed 32 kilometers per hour. My distance from my home position was this amount here, 231. Mostly I started out with 11 sats. I had 14 when I ended. That's very nice. My minimum voltage was 13.6. My maximum started out with 16.4. My current at idle was 0.5. My average nominal flight was 17, and my maximum current, most likely when I was ascending, was 30 amps. And same thing with wattage here that reflects the amperage. This is the capacity of milliamp hours that I used on this flight. And my 6 motors, this is the amperage in the same sort of configuration where it was idle, nominal, and maximum amperage per motor. And temperatures are all 0 because I don't have temperatures installed. And then this is the magnetic field, which is everything is fine. I did have a couple errors and warnings. Low battery occurred 2 times, and I decided to come in for a landing when that occurred, which is what you should do. So, getting into the actual log file, we will take a look here. This is when things occurred. You'll see. So let's start here at the top, and you'll see that here's the log file started when the motors were initialized. There's no log file prior to that point. So this is the motor run on, and fly is on, even though I'm not airborne yet. I'm starting out with manual control. Carefree mode is off, altitude hold is off, position hold is on because I want to go straight up. I want to hold that position. There's debate whether that's a good idea or not. Coming home is off. GPS is solid. And barrel trim up and down is what I'm using for ascension. There's no error codes, low sats, there's no failsafe, everything else is fine. So you can see here that for the first couple of logs I took off in manual control. Then over here at altitude hold, after I got up a little higher, I flipped on altitude hold. Position hold was already on. And during this time I used altitude varl to ascend, and then I held here. And if you come over here, I went back to manual control for a while, probably just to get my orientation, and then flip back to autopilot again. Okay, this is my graph of voltage and current, and you'll see here that the green line is voltage, and the thing we want to look here is we don't want to see this green line dip ever. We want a nice solid straight line all the way across. Okay, current is going to be all over the place. That's the blue line, and that's because the motors are always taking different currents. We don't want to see anything excessive, and we don't want to see the current drop to zero either. But this is a normal current graph. The next thing is the individual motor currents, and they should all be about the same. If we see anything unusual here, we probably have a shorted turn in one of the motors. Something's drawing too much current, or one of the motors is not even on and just drops to zero. The hexacopter can fly with a bad motor, since there's 5 more to maintain stability. Okay, the compass, if you notice when I first took off in manual control, I was pointed south at 180 degrees. Then I turned west, then went back south again, and turned north, then went so on and so forth. So that's basically which way I was pointed at what time. And let's look at the sats versus altitude. So when I first took off, I was at 0 feet, meters. I rose to a hover height, and I believe that's what's that saying, an altitude of about 14 meters to hover for a minute. Then I flipped to auto and went up to what I went up to 48 meters for a while, and then I went up to 71 meters. Okay, and so on and so forth. This is the altitude of my flight. The green is your satellites. I've started out with 11. I only need 6, so 11 is nice, very, very nice. And then increase to 12. And then further down the road here, we increase to 13. And finally, I actually got 14 satellites, which is quite amazing, and partially due to the copper shield I put around the GPS board. Okay, so let's go over here to capacity graph, and this is the milliamp hours I consumed as from the battery. And the sticks, this is the actual position of the sticks in case there was a strangeness with the sticks. In other words, like the elevator stick is the green one, and the blue one is the aileron, and the red one is throttle, I believe. Okay, so this is the map, And here is the hexacopter right here. And this is my route. This is the KLM file of where this trip occurred. This is my virtual OSD. The virtual SD basically tells you in real time at any moment what's going on. This is the time, this is the milliamp hours consumed, my voltage, my current, my wattage, artificial horizon, compass, direction, elevation, altitude, speed, blah, blah, blah. These are all the switches. In other words, right on this thing I'm enabled with my fly, meaning motors are on and running. I'm on manual control and I'm in position hold. And this is the actual sticks themselves, the position of the sticks, and this is the different PODIs as they call them, but basically they're functions. And I have different functions here like to tilt the camera and some other things like altitude hold, position hold, switches, and things like that. So that brings us to this guy, which is the player, and we're just going to play this entire flight. So here we go, press play, and you'll see that I took off, and then you'll see all the different graphs at different points what was happening. In case I had a problem, I can stop this and take a look as to what happened, and you'll see that I'm flying this course down here. You see my altitude's going to increase because I had to go over the trees here. So when we come back here, this is the coming home test. And here's my virtual OSD. And I'm running this thing fast, so we can show an entire 15-minute flight in a couple minutes here. So that's why it's bouncing around quite a bit. You can change the speed here. We can go to single speed again, in which case things are nice and smooth. Okay, so these are the positions of my actual transmitter sticks as I was moving them around the fly. And these are the positions of the different switches in case I want to, if I switch to different modes. I'm only using the first 4. You can just see that P4 just went from on to off. So the GPX tool is quite valuable for doing post-analysis of your flight. And everything is logged to the micro SD card, which you have to remove from the flight controller and pop it in your computer to take a look. All right, that's it.